Okay, today is a lot of geometry essentially, but not hard geometry. Actually, a lot of it's some stuff that we've already done in class, just taking it a step further. So today we're learning volumes and surface areas of three-dimensional shapes. Yay. So it's not hard stuff, it's just memorizing the formulas and knowing how to throw numbers into the formula. So it's nothing too hard. So let's start by reviewing the area of a circle.
Of circle or sphere?
Of a circle. Because then you can use this as a base for like a cylinder. So since we just reviewed this in class, who remembers how to find the area of a circle? Robert?
I think it's pi times radius squared.
Yes, it is. It's pi times our radius squared. Okay, so go ahead and try these two. Find the area of this circle that has a radius of 5 and the area of this circle that has a diameter of 12. Go ahead and try those. Okay, what do we get for the first circle? Sophia, what'd you get?
78.54.
75 what?
78.
Oh. 78.54. Is that about what everyone else got?
Yeah.
Okay, do we need to review how?
No.
Okay. So on some teachers would allow you to leave it as 25 pi, but some will not. So just a heads up about that. Yeah.
Oh, I was gonna.
Okay, you got the second one?
Yeah.
Okay, what is it?
13.09. 09.07.
Can also be
113.1.
Okay, so maybe depending on how you rounded yours or how many decimals your calculator does to pi, somewhere around here. Shh, Jared. Any questions on these two, finding areas? Awesome, good. If your decimal was a little different, that's okay. Because everyone's calculator's a little. All right.
You know that's 6.
So who can?
Oh, never mind. It's because she did the 12, not the radius. She did the diameter.
Ah, okay, so that's a good one. And I tried to trick you with that. So yeah, always watch in case they're giving you the diameter instead of the radius. So in this case, you'd have to divide it in 2 to make sure that you're doing 6, not 12, because that will mess up your entire thing. Well, it's not so much trying to trick you. It's trying to that you're not just taking any number that's there and throwing it into a formula. It's the fact that you understand that it is radius squared, not just whatever number's there. Right? Yeah. I like coffee really hot. Okay. So now let's move on to finding volumes, which should be a review from class. Okay, rectangular prisms, which are boxes. It's a fancy word for a box. But it's because they have a rectangular side and they're a prism. But it's a box. Yeah, it's okay. It's not very symmetrical. All right, who remembers the formula for this? Isaac.
Base times width times height.
So,
Length times width times height.
yeah, be careful when you're saying base, because you could say it's your base times your height, and then we can break down base into your length times width times height. So either of these technically are correct. Yeah, that is how you spell height. And for most things that you're finding the volume of, base times height is how you're finding it. It's just what shape the base is going to change. If it's a rectangle, if it's a triangle, if it's a circle. So base times height is a good way to remember volume. Because for pretty much everything except for spheres, because spheres are weird, it's going to work. So what is the shape of the base of this shape?
A rectangle.
A rectangle. That's why it's called rectangular prism. So if this shape, let me think of some numbers. Let's do 3, 5, and 7. Go ahead and find the volume of that. Okay, who's got the volume of this?
105.
What'd you get?
105.
Is that what everyone else is getting?
Yes.
So this one, remember, it always kind of like, with this one, it doesn't really matter which one you define as your base. So you could have like this top area be your base, or you could have this side area be your, it really doesn't matter. And then you're just taking your base and it's timesing by the height. So if these were like sheets of paper, it's like the area of that sheet of paper is this, and then we have this much of sheet of paper. So that's how you get to volume. All right, so that is rectangular prisms. Let's move on to triangular prisms. So triangular pyramids have a triangle as their base. That's why the name, triangular pyramid. So we can still do base times height, but what's the shape of your base? A triangle. So whichever way that it's oriented, you're going to want the triangle to be considered your base. Okay. So since it's been a while, I need a new color. Since it's been a while, how do we find areas of triangles? How do we do triangles? Charles? Is it just base times height?
I think they're just base times height.
Yes. So it's base times your height over 2. Because if you do base times height, you're actually getting a square with those same things. So that's why we have to divide it by 2, because there's 2 of them.
Oh.
So it's like when you have your sandwiches and you cut them diagonally, because it has the same dimensions, but then you get 2 of them at the end.
2 sandwiches?
You get 2 sandwiches.
But
That's
it's only
awesome.
the sandwich.
It's still the same.
It's not there.
But if you do that with a 2-year-old, they're not there yet mentally, and you can actually convince them that it's 2 sandwiches.
Really?
That's what I do with my brother.
No, like they're at that age where you can also give them like 5 pennies in exchange for like a quarter, and they'll honest to God think they have more money because they have 5 and you only have 1. They don't understand it yet.
Yeah, but it's not sandwich.
Okay, find the area of this triangle. Go.
Kid with the $50 bill.
You got 5 ones.
1, 4,
Find the area of that triangle.
12.
Okay, so what do we get for the area of this triangle?
12.
Whoa, I'm hearing a lot of things. What?
Wow.
Oh, 12.
12 units squared, right?
Yeah.
12. Because 6 times 4, 24, 5 by 2, so we get to 12. We're all good on that?
Wait, why was it? How did we get to triangle?
Well, it's the units are squared because this is a 2-dimensional shape.
Oh, okay.
So if you're finding area, it's the units are squared. If you're finding volume, the units are cubed because it's a 3-dimensional shape.
Is there anything you can put that short for units instead?
UN. Math really isn't complicated. Okay, now what about a triangle that looks like this? How do we find this kind of area? Caitlin?
It's the distance from the top, the point, down to the base.
Right, so 5 is our height. But what do we do about that 6?
You divide by 2.
You could divide it by 2. So that would give us essentially
3 on either side.
that this part right here is 3. Okay? But then now what do we do? Yeah?
You can do the same process for the triangle above to find what half of that triangle
So I need to do 5 times 3 over 2?
is. To find what half of that is.
Why half?
Well,
Why not just
because are you trying to find out what the entire triangle is?
I'm trying to find the entire triangle.
So
then
if you do that, then you get what half the triangle is. Then would you be able to times that by 2? And then
If you're gonna it's the same. Divide it by 2 and then multiply it by 2 again, you don't.
Okay. So
So,
there's a couple different ways of looking at this. Some of you like the method of doing the whole divide by 2 because that essentially gives you the area of this guy in here, and then you multiply by 2.
But is there no point then in even dividing?
But some of you know that, wait, if I'm dividing by 2, multiplying 2, those are the same exact thing. So actually all we need to do,
so you
Five times 3.
5 times 3, so what's this area?
15.
15.
Oh,
Wow.
this
Facts.
Okay? So always check what kind of triangle it is you're working with.
Wait, don't.
But then make sure in this ones you have to remember that you're not multiplying by 6, you're multiplying by 3. Okay, so now let's take that, now that we know how to calculate the base, and bring this into volume for our triangular prism. So now we know that that's how we're doing to find our base, and all we need to do is multiply by the height. So let's say this is our triangular prism that we're trying to find the volume of. We're going to say that it has, that's a really bad straight line, a height of 3. We're going to say that this bottom area is 4. And let's say that this length back here is, I don't know, 7. See if you can find the volume of that. So remember, the base is this front area, this front triangle, and that's the height, even though it's not height, it's still height. So go ahead and try to find that one. So I'm hearing a bunch of different answers. So someone walk me through how we solve this. All right, what do we
You
do?
multiply the height.
Okay, 7.
I'll do it. And then the 4, and then 7,
We do 4 times 7
and then times 3 too.
times 3.
And then you divide it after you get the answer.
Why would we divide it after we get the answer?
I don't know.
If it's base times height, why would we divide anything?
I don't know.
Joey?
And why would the 4 times 3 be the size of the base when triangles you'd have to divide by half for the finding the base?
Right,
Base
so
times height.
I think we all agree that height is 7, but we're all kind of confused on what should be our base. Ian?
Okay, so we just learned how to find the base over there, right?
Right.
So if it's a triangle, if it's a right triangle, and then it's base times height divided by 2. But if it's a triangle like this one, right? We found it on the bottom. It's base times height. That's it.
Right, so you always have to look at what kind of triangle it is. So since this is the kind of triangle that we just did, where it's just base times height, we don't need to divide by 2, but the only thing you need to make sure of is the fact that your base isn't 4, your base is 2.
So you get 6.
So you would
6
need to
times
do
7, which is 56.
2 times 3 times 7.
Which is 56.
Isaac?
So it could be considered as height times length over 2.
Yes. Wouldn't it? That's the right.
Height times length over 2.
Because the bottom number is 4.
One person at a time.
Technically your 4 would be your length, and so if you divide that by 2, like length over 2.
Okay. Alright, so that's why you're saying that. So you're saying, I'm hearing a lot of extra talking, Jared, and if you want to talk, you can go outside. So he's saying he was defining 4 as the length, and so that's why he was saying length times height over 2 to take away the fact that our length essentially needs to be divided by 2. So you're just kind of doing it out of order, but that's actually okay. So always just make sure, however you're getting your base, you should be finding that the base of this is 6. However you found that, your base is 6. And then you take that base times the height. So this should be 42.
Oh, so I was thinking 8 times.
We did get it right.
You got 42 though.
But why can't you just divide it at the end instead of getting
Well, you guys, yes, technically got the right thing, but you didn't know why you did that.
Wait, but would it work in any kind of situation?
No, that's the problem. So you guys got lucky that it worked this time. It wouldn't work if it was a right triangle. So that's why I didn't want you guys saying that, because it's not going to work every time.
Yeah, it's, why is it because
Because it's this kind of triangle, not this.
then why is it 2? Then why is it 2? Then why is it 2 times 3 times 7?
Because just like over here, how it's not 6 times 5, it's 3 times 5. So same thing over there. It's not 4 times 3, it's 2 times 3. You have to take half of this bottom area because you're finding essentially the area of this triangle and then multiplying it by 2. Because the formula we know for triangles isn't how to find these kind of triangles, it's how to find these kind of triangles. And so you have to recognize the fact that these triangles are essentially 2 right triangles next to each other.
Okay.
Yeah?
Maybe I'm wrong on this, but like, wouldn't you have to do the 5 times 3 and then, oh wait, never mind, because yeah, it cancels it out.
Because it cancels it out. So you could do 5 times 3 divided by 2, but then times 2 because to count for there's 2 of them. But you don't even need those. So you could do the same thing over there, 2 times 3 divided by 2, but then, oh, there's 2 of them, so multiply by 2. You can do all that. That's why I always tell you guys, just remember base times height. So find the area of the base, however you want to find it, and then multiply by the height. Yeah, you're essentially finding half of the base and then multiplying by 2. But remember, that's only going to work if it's this kind of triangle. If you have a right triangle as your base, then none of that really matters. You're just going to do base times height divided by 2 to find the area of the base.
Those triangles are
Yet they always like to do them. Questions? Triangles are weird.
Well, then again, if there were a triangular prism that had a right triangle as its base, then
Let's see
that
if I can draw
prism
that.
would look very funky.
Not necessarily. Let me see if I can draw one. I'm not very good at drawing these, so. Right?
Oh, it's
Oh, yeah, it looks like it.
So like the face of it is this guy.
Yeah.
But
But it's like half of a tent, because like one side's up and then the other's like out.
It's like when you're setting up.
It's like you drew a tent at an angle.
So in which case, if you have this, shh, Jared, do you need to leave?
No.
Then I shouldn't hear you talking all the time. So if you had this kind, then you're doing your base times height divided by 2 times whatever your height is. How do we feel with these? We need another example to work through?
Yes.
No.
Yes.
No.
Okay.
so
Yeah.
when you have the right triangles, can you still just divide one of the sides? Like how you did with the other triangle?
You won't need to though. The whole reason we divide one of the sides is because we want to calculate a right triangle. But here we already have a right triangle.
Oh, okay.
So this one's actually going to be easier. So actually let's find this one. So let's do, this will be 3, this will be 5, and this will be 6. So go ahead and find the volume of this one. It's a right triangle face with the dimensions of 3 and 5 and then the height of 6. Go ahead and find that one. So this one we do have a right triangle to work with. So you can do it this way.
What?
You know, I mean, like, couldn't you just, for the 6 times, it would be 6 times 4, so couldn't you just divide the 4 into 2?
Yeah.
Because, yeah.
To account for, yeah, we could do that.
You have to times 6 though.
Oh, that means even from a right triangle,
Like,
if you change the 4, and then if you divided the base yet again, you still get the same as a non-right triangle.
Yeah.
6 the height?
Oh,
No, 5 is the height.
Oh, with right triangle, you just divide.
Isn't it 5 times 3? 'Cause that's the basic height.
So to get the face of it, you'll do 5 times 3 divided by 2, and you'll take that and times it by the 6.
Oh. It's 12.5. Yeah, 75. What's 50? I do 12.5. That's
What's
not
that? 12.5.
Oh,
I got
7.5.
I got 45.
7.
No, I got 45.
Oh, 7.5. 7.5. I got 45.
45? What are we getting up here?
We got 45.
45? What do you get? 45? What do you guys get? 45? What do you guys get? Is everyone getting 45?
6 times 4 with the height.
Are you saying for
No, someday.
Yeah, but they
So all of this together, I'm hearing pretty much that we're getting 45, Joey. Because most of you recognize the fact that it'd be 5 times 3 divided by 2 for this front face right here, and then multiply by 6, and we're getting to 45.
Yeah.
We all feel good with that? Okay, all right. Let's move on to our next shape. All right, so let's move on to cylinders. So hopefully this will be a review because we just did this in class.
Alright.
Yeah, of course.
So,
Why don't we learn like the final all the areas and volumes of these other shapes of math instead of like just this?
Why don't we find what?
Because we were finding like the volumes of like triangular prisms and rectangular prisms. How come we didn't do that in class?
I don't know. Your standards are chess on rectangular prisms, cylinders,
This is what we're probably learning geometry.
and spheres.
I mean,
I don't know why we don't do triangular prisms, and I don't know why we don't do surface area either, because we're going to touch on that today.
oh, we are?
Yeah. Let's keep talking to a minimum. Okay, so now we're going to remind ourselves about cylinders. We just did this in class, so this really should be a review. It still is your base times height, but what is your base?
Surface area.
It's a circle.
It's a circle, okay? So you're still doing base times height, but the base is a circle, okay?
Oh, pi times radius squared, and then just times the height.
So how do I find the area of that circle? Caitlin? So your base is going to be pi r squared, and then you're just going to be multiplying it by your height. And that's the formula you should remember from class. Because your base is going to be that circle, and then just multiply by height. It's that simple. Everyone draws pi signs differently. I do squiggly with 2 lines. Some people do straight line with one coming off it like that. Some people do 2 ways of that. Everyone's different. That's totally fine. Okay, take a second. Find the volume of this cylinder right here with a radius of 5 and a height of 7. Go ahead. Okay, what do we get? Wow, that's a lot of numbers being shouted at me. I need one person. Dan, you're talking too much. Lily. Something like that?
7787144.
Close enough. So, anything about that we need to go over? Or we still feel good with these? Yep. Yeah, so the units, whatever the units are is cubed. So it's not that you're cubing the number itself, it's the fact that the units are cubed units. You're saying how many of these cubes essentially fit in there. That's why it's cube units. Okay, we feel good with cylinders? It's not too bad if we remember it from class. All right. All right, then spheres. It's the only one you can't do base times height with. This is the one that you really have to just memorize the formula for. Okay, especially since the formula is a little weird, since it gets derived kind of in a weird way. All right, Mimi, what is it?
4/3 pi r cubed. Calm down.
And if you don't like fractions, something that Isaac figured out is it's the same thing, but divided by 0.75. If you don't like fractions. So if this is easier to put in your calculator, totally fine. It's the same thing. Just some of you, because I mean, this would be 1 step, whereas this is 2 steps for some of you in your calculator.
Times 3 divided by 4 for the 4/3.
No, it's times 4 divided by 3.
Oh.
Oh wait,
But then that's
Wait, we don't really need to do that.
Yeah, it is 1 and a third.
We need to give us the diameter so that then.
Wait, what is radius?
Wait, yeah.
wait, how do you get from 1 1/3 to
Radius is half a
7.75?
So, the way that works is instead of multiplying by 4/3, you're doing the opposite operation of dividing by 3/4.
And
It is called.
And then doing the reciprocal.
Reciprocal.
So you're doing the opposite operation with the reciprocal, and it still works out. But instead of saying you're dividing by 3/4, that's the same thing as dividing by 0.75.
Oh, I see.
Oh yeah, because when you divide by a smaller number, it's
Mm-hmm. Yeah. So either one of those is fine. I know most of you now memorize this one, so that's totally okay. So we have ourselves an oddly drawn sphere. We're going to need to find the volume of this. Let me think of another. Let's be mean. 17. Okay, so this sphere has a diameter of 17.
You're gonna give us a decimal then.
So go ahead and find the volume.
I love evilness.
Oh,
I get 13.5.
Yeah,
13. No.
8.5.
8.5. 8.5. I corrected myself. That's what matters.
Oh my gosh, on his calculator.
I did.
205,700.
No.
Yeah.
Go back.
Turned it off.
No, the last thing I did was
How would I explain that? Exponent
syntax there. Okay, so high button.
I'll check you in a second.
Well, you have a cube button right there.
High button.
So it's pi times.
Alright, use your pi button. It's more accurate. Use your pi button.
Pi times 17 times 17 feet.
I already get away.
2,572.
High
So
button.
you got
And then it's 8.5. That's correct with the syntax. Because it can't handle all 3.1, 4, 5, 6, 7, 9. I know it's like 5.
It didn't like that you didn't put in parentheses.
What? Okay, then I'm just gonna use 3.1.
try dividing my data.
It doesn't actually really matter as long as it gets.
It shouldn't, no, because it's not negative. But your calculator, I guess,
Oh.
Oh,
actually, you don't. Oh, you would. Oh, for yours, put in 8.5. Then hit that cube button. And then hit.
I think he did a little bit of mix up.
We're talking about a sphere with a diameter of 17.
I did something wrong.
Yeah, that's all. Like 1, 4, 1, 5.
Maybe. 3.14.
You can't cheat it.
1, 5, 6, 4.
1,592,654.
Okay, what are we getting?
Oh.
1,500.
Okay,
I got 2,572.44.
2,500.
72.44.
Is that about what everyone's getting? No? Okay, so let's go over this. If you're talking, you're wasting our time, Ian. So the way you would put this in, and depending on your calculator, it might be a little different. So what's our radius? 8.5. So I would probably put in 8.5 cubed into my calculator first.
614.
So that's 614
With decimal.
with stuff.
125.
Then I would multiply that by pi. So whatever that is.
1,929 point whatever. 1,900.
Then
1,900.
Then what I would do is then do the times 4 divided by 3 thing. So is that the part you messed up? The times 4 divided by 3?
No, I did the diameter.
Ah, see that always messes with you. And they will always do that to you. Because they want to make sure, because they want to go beyond, do you know how to throw something into a formula? They want to see, do you actually understand what it is you're calculating? And the fact that the formula uses the radius, not the diameter. So don't just always take whatever numbers they give you and just do stuff to them. Make sure you're using the right numbers. Okay, how do we feel about spheres?
Good.
We're okay with them? All right.
Did you say how do you feel about cubes?
Spheres? Pretty sure it says spheres.
Never change your
Okay. So we're gonna be moving on to surface area, but something I want us to review first is how to find the circumference of a circle. What's circumference mean?
It's like the rounded.
It's around it. Yeah. So it's the measurement around a circle. It's the perimeter. So if I took a string and wrapped it around this circle, how long is that string gonna be? So it's actually a one-dimensional measurement.
For a second, I was thinking of we were gonna do it with a sphere.
Not yet. We're getting there. Okay. Does anyone remember the formula for this? Probably.
No,
It does have pi in it. Whenever we're dealing with circles, we have pi.
nobody knows.
So there's two different ways you can think about the formula. You can either think of 2 times the radius times pi, which is also the same thing as the diameter times pi. Either way you like to think about it,
Oh, by the way.
because 2 times the radius is the diameter.
Oh, diameter.
So you can either do diameter times pi,
2r.
because 2r is diameter.
Yeah, but that's like much
Some
more
of them don't
standard.
have radius.
Not fun.
But if they give you radius, you're going to have to multiply by 2 anyways. Right?
So actually, technically, the left there is the better one.
Well, it depends on what they give
Depends
you.
on what they give you.
It's better no matter what.
So find the circumference.
If you have the diameter, then what's the point of finding the radius?
So we have a radius of 6. Find the circumference. Yes.
Oh no, I think it's.
Give people a chance.
Gosh, Joey.
Will you?
Get away.
So
Jared, if you're not using your time wisely, you don't need to be here.
in 2 and 6.
I put on my pi settings like that. Is that weird? It's like 2 bumps.
3, 7, 9, 6, 9, 9. 6, 9, 9, 1, 9, 8.
I argued that.
Wait.
2r. 37. Yeah, 37. 37.7.
It's not square.
Yeah, wait, how did it 7?
Yeah, it would be
I got 6.
correct. It would be squared.
We round that up.
All we're measuring is around. So it's a one-dimensional measurement.
I've actually got a question. So when you're rounding, do you have to round the smallest number? Do you round from like the farthest back number up?
No. So
So
if wherever you're wanting to round, so depending on how many decimals, so let's say I want to round to 4 decimals. I look at the next number, that next number says, oh, we're going up, so this becomes 3.2588. That's it.
so you would not take the 2 and round down
No.
to 524 then?
No, it's just wherever you want to stop. Maybe I want to stop here. I look at that next number that says we're going up, 3.26. It doesn't matter what the rest of them are.
That could actually make rounding very complicated.
Well, but think about like how would you round something like pi if it never ends?
I forgot to tell you what time is that one day.
So x is equal to the opposite of b plus or minus rounding.
I forgot it.
Well, it's recorded and on YouTube, so.
It's on YouTube.
Are you gonna delete the videos that you have on YouTube? Like,
They're public.
from this year?
Yeah, they're public already.
No, like my friend next year, are you gonna delete them and make new ones or just leave them?
Oh, I think what I'll do is I'll still have them available. Like, hey, if you want to see like what we did last year as like a supplemental thing. I don't know how much things are gonna change next year or not.
And if they weren't to change at all, would you keep it exactly the same?
Yeah, maybe just like input like newer stuff or better whatever.
Make a new channel and leave the old channel for us.
Okay. I don't. Yeah, I
And
have
it's
no
just
problem with that.
really easy. And then you
If you
just
have
like
the same.
Okay, so who's got the circumference for me from this? Yeah.
37.70.
69.
I got 60.
Okay.
I got 60.
Shh. Okay, decimals don't really matter. So everyone got about 37 stuff?
Yeah.
Okay. Now, should units be like this? Should they be squared?
Nothing. It's area. It's perimeter. So
It's- It's
not-
perimeter. It's a one-dimensional measurement, so this is just fine like that. Okay, quickly, so we can also move on. Let's do. Go ahead and find the circumference if the diameter is 2.54. Go.
So if like
Oh, I was just using 2.54 times
if
5.
the answer was 37, like 7, but somebody got like 36, like 9, would you then like
Equals 7.97.
7.9.
I have one.
No.
I got 15.
Yeah, that's what I said. Like 9.7.
No, I want.
Yeah.
Mine's like 3.14.
Yeah.
Even though I can tell you guys.
It sounded like you said 0.97.
I don't know, like maybe.
No.
Probably did not. I
The
know.
point is that they understand what they
I
are.
just said that. You probably did not know.
yeah, but that's get the answer right and write it down.
Where I might see it as like something that brings more useful, very valuable. You might see it
It's Cage, Daniela.
It's not even hard.
You're multiplying, right? Take that diameter and multiply by 5.
regular
So
sweater.
it should be
And
like
at
6
first
something,
it's
right?
as a sweater thing.
Whatever.
It's every other color.
No, like 6 and change, 7 and change.
That is the worst pun I ever heard.
Black, green, and that's my
Okay, what do we get?
Oh.
Yeah,
7.98 units.
Whoa, whoa, whoa.
7.98.
Yes.
Yeah.
That's what I got.
Questions about why, how?
We go over it.
Yeah.
It's like.
So this one, because it's diameter, you can use this one. But even if you forgot, even if for some reason all you remember is this one, then you'd be like, well, divide that in 2 to get radius, then multiply it by 2 to get the fact that it's 2. So you're just doing 2.54 times pi. So automatically, like even I was trying to think what this answer is going to be. Well, you're doing 2 and change times 3 and change. So already you know you're going to be in like the 6, 7 range.
Because I heard you say that solve it if the radius is 2.55.
But look at the drawing.
I know, but I was just reading by her words of wisdom.
If anything, I always misspeak. I never miswrite. That's a lie. I always miswrite too.
Well, not always.
But less often than I misspeak. I misspeak more than I miswrite.
Yes.
That's because you say words fast.
Not trying to sound offensive.
I was correct.
Okay.
Why are you being mean to us?
Hey, we already wasted a lot of time. We have surface area of tons of different shapes to get through, and we only have about half an hour left. So we're going into surface area. Surface area is super annoying because you essentially need to find the areas of all the sides and add them up. Okay? So pretty much whatever shape it is, it's find the areas of the sides and add them. So yes, most of these have really complicated formulas, but honestly, I wouldn't remember those. I'd remember find every single side and just add them up. Okay, so regardless of the shape, except for spheres, because spheres are weird, rectangular prisms, triangular prisms, all of those cylinders, it's you find the sides and add them up. So a rectangular prism, which is a box, let's say we have 2 and 3 and 4. How many sides does a rectangular prism have? 6. If you don't remember that, think of a die. Dies go up to 6. A regular die, a cube die goes up to 6. Okay, no Dungeons and Dragons sort of dies here. So Something unique though about rectangular prisms is what all the sides essentially have a pair. So this front side has an identical side on the back. And this side over here has an identical side on the other side. And this side over here has an identical side on the other side.
So you only need.
So really you only need to find those three and then multiply it all by 2.
Then when something is more complicated,
So
like a
multiply
triangular
all of
prism,
them, or add
takes long.
So-
them and then before?
What is the area of the purple side?
Oh.
that'd
2
be
times 3 times, so that'd be 2 times 3,
6.
but there's 2 of them,
So 12.
right? Because there's front and back.
12.
Oh yeah.
So that'd
So
be,
it's A B B C A C times 2.
What the?
what is the area, what is the area of the red side?
2 times 4.
2 times 4,
Times 4.
but there's 2 of them, right?
So there's 16.
Because there's this side and there's the other side that's hidden. So it's 16. Switching colors too many times.
And then 24 for the next one,
And then the orange side was that 3 times 4,
which is 12. And then
but there's
2.
2 of them.
Wait, why is it?
So A B B C A C.
Because it's this side, which is 3, times 4, which is that side, but then there's 2 of them because there's top and bottom.
Yes, I understand, but 3 is the top and the bottom, so it would be 3 times.
It's 42.
Well, so we're doing orange, this top, so this side right here is 3, right? And this side right here is 4,
Yes.
so it'd be 3 times 4?
Yeah.
Okay. But then we times 2 because there's 2.
Yeah, there's 2 sides.
Okay.
Then
So
you get 52.
if we add these up, what do we get?
52.
Is that what we get?
You'll see.
I got 42.
Did you carry the 1?
Carry.
Yeah.
Well, I don't get like so. If you're doing the 2 times parentheses 2 times 3, wouldn't that get you 4 times? So that would be 4 times 6. So that'd be 24.
No, it's 12. 4 times 3 is 12.
But it would be 4 times 6 because you're putting it on the 4.
4 times 6 is still 24.
No, you're right. It is 52.
Right.
So once you carry the 2 and the both of them, making it 4 times 6.
Well,
No, that'd be 8 times 6.
Where are you getting this 4?
Yeah.
With which, this last one?
The first one.
Distribute the 2 into everything, which would be 4.
4 times 3 is 12.
So,
6.
okay, so when you're right, but when you distribute it, you only distribute it to one thing that's being multiplied. So think about the fact that like if we have 3x and we have a 2 outside, when you distribute it, it becomes 6x, not 6 like 6 and 3 and oh my goodness, I'm keep misspeaking, 2x. You're not distributing it to both 3 and the x. The 3 and the x are multiplying, so you only need to distribute it to one thing. So it's the same way with our 2 and our 3. Like you can think of the 3 as that x. We don't need a second distribution. It's already being distributed to it. So you're thinking about addition.
Wait, couldn't that work out like when you just like distribute like the 2 into the other 2 and then just multiply?
So yeah, you could do 4 times 3.
Oh yeah, I was like looking.
So that's the same thing. Yeah, if I distribute that, it's 4 times 3. That's the same thing.
Yeah.
And same thing here. You could do 4 times 4. It's the same thing. Or 6 times 4. That's the same thing.
Did you always multiply? Oh, yeah, yeah.
Because multiplication doesn't matter what order you're doing it in. Yeah. Okay, go ahead. All right. Questions on this one? Because we don't have time to do another one. Okay, so remember, rectangular prisms, you have 3 sides, and then remember that really there's 2 of those sides that you're calculating. So there's 6 total. Yeah.
Is this test gonna be very long? Just like that?
Yeah, depending on, I mean, it's a lot of details, depending on how fast you are with your calculations.
Oh.
Because we have to essentially do one of each kind.
Except for spheres, hopefully.
except for spheres, in which case you just memorize the formula.
I thought you meant
I hate triangles.
Well, whining about it's just waste our time. It doesn't actually help anything. Triangular prisms is pretty much the same thing. Find the area of all the sides and add them up. The nice thing about these, though, is there's only two kinds. Actually, no. There's nothing nice about these things. I'm going to change my mind about that. Well, if it's an equilateral, then all the sides around would be the same. But if they're not, then it won't be. And it'll be annoying.
Be completely equal.
So, with these ones, let's make this 3. I'll be nice to you guys. Let's say that this part right here is a 2, and this length right here we'll make is a 5. So we have to find the area of every single side and just add them up. The only thing that's nice about it is the fact that our front face is going to be the same as our back face. So how do I find the area of this front right here? Dan?
3 times 2.
So we're going to have 3 times 2 for that front, and then there's actually 2 of them because there's front and back. So that would be 12. Okay. Now, this one we do actually, it's, why am I missing the name of it? What's the name of it when there's 2 sides that are the same of a triangle? It's not equilateral. Isosceles, thank you. So this is an isosceles. So we actually have 2 sides that are going to be the same, but they don't give us that side right there. How do we figure that out?
Yeah, it's 3.
The Pythagorean theorem.
We learned about it. You know, it's where isn't it where if the right triangle and the longest side is always gonna be like C, and you always like destroy this A and the medium C, and the longest is C.
If you're whining and talking to the person next to you, you're just wasting our time. Okay, so Pythagorean theorem, remember, a squared plus b squared equals c squared. Most of the time it really is that you have a and b and you're finding c because it's the diagonal. So you would do, okay, 2 squared, so we got 4 plus 9 equals 13. So, but we have c squared, we want regular c.
So square root it.
Square root it. So in this case, we really do need what c equals. So we need to find the square root of 13.
Yeah, 3.6.
3.6? Awesome. So that diagonal is 3.6. Okay. So you can't forget things in math. Everything comes back around. So if I want this side, well, it's just a rectangle. It's 3.6 times 5. But conveniently, there are 2 of them. Oops, this is a plus. So who's got 3.6 times 5?
18.
18, exactly. That's convenient.
And then times that by 2
And then times 2?
is 36.
36. Okay. And then we have one last side to find. It's that bottom side. So that's going to be 4 times 5,
It's 20.
which is 20. So now we have all the sides, and we just add them up. So 12 plus 36 plus 20. It is a number. You are correct.
68.
68. Okay. So surface areas are annoying.
It's just units, right?
Yeah, I didn't give you what the units were, so it would be units squared. Because it's the areas, it's surface area.
What about the circumference of a circle? Is that just units?
It's just units because it's just a one-dimensional measurement of the outside. Okay. Oh goodness. Okay. 2 more and then we're done.
And then we take the quiz.
And then you take the quiz and do one of every single one.
How many
Okay.
pages is it?
Cylinders actually aren't that bad. There's only like 3 parts to it. So with cylinders, there's essentially 3 parts. You have the circle on the top, you got the circle on the bottom, and then you got this rounded outside part, which is where circumference is going to come in. So if I wanted the circle on the top, that's just the area of that circle. So how would I find that here?
3 pi.
Okay. And is the circle on the top going to be the same as the circle on the bottom?
Yes.
Yeah, so this one we can multiply by 2. Because there's 2 of them. They're exactly the same. You don't need to. So this is the area of that circle, but there's 2 of them, top and bottom. Then, what we have to do for this rounded part, you have to think about how you find that, like if I wrapped a piece of paper around a soda can. It really is a rectangle when you unravel it, but that length along the top is the circumference of the circle. So you have to do the circumference times the height.
So 6 pi. 6 pi 7. 6 pi 7.
And is it times? No, it's pi.
So yeah, so that would be 6 pi times 7. But that would actually be it for the cylinder. So cylinder's not too bad, as long as you remember what you're doing.
So it's circumference times height really.
Times the height.
Wait,
So who has this? Oh yeah? Okay.
Where's the 6 coming from?
From the fact that, remember, circumference is the diameter times pi. So you can either do 2r pi, or just the fact that 2r is, well, it's the diameter. So 3 times 2 is 6. So who has this first part for me? 9 times pi times 2. What is it?
56.5.
Who has this second part for me? 42 times pi.
131.9.
Okay. Add them together.
That's
I got it. No, I got it. You have it at 188.5.
5.
Oh, Jared.
43 on me.
I got a 0.496, so 1.5.
I'm not gonna start fights. Okay, so you get 188 and stuff. And remember, this is units squared because it's surface area. So rectangular prisms, triangular prisms, cylinders, you're just adding up all the outside stuff. Okay? It's just remembering what those shapes are that is really going to trip you up. Spheres is where it gets weird, so it's just another formula for you guys to remember.
How many more do we have?
Spheres is the last one.
So we only have 1 more?
Yeah.
Can you do the,
Is this gonna have
What?
I think,
Is this
can
gonna
you
have
do the, triangle prisms?
Go over it again? Sure.
right now?
No, after. I'll get you the rest of you started. Okay, so for spheres, we're not going to go into how this formula came about. It's this really long, complicated method. You can YouTube videos if you want to find out how this works. But it's a little bit beyond you guys. So just remember it's 4 times pi times the radius squared is all that's required of you.
That's really simple.
It is really simple. So spheres are always the weird one because there's no like roundabout way to remember it. You just have to remember the formula. But sometimes that's better.
Doesn't the area of the sphere, 4th roots pi are cubed?
Cubed.
So it's actually similar to that.
Okay.
Other than it's
Well,
not
but then you have to make sure you
square.
don't get those mixed up too, right? So if the radius of this was 7, find the surface area of the sphere. Basically, if I'm painting the sphere, how much paint do I need? That's essentially what we're finding out.
That's not fun.
615.75.
Okay? We'll wait to see if someone can confirm that.
Oh.
Yeah, 615.75.
615.
Yep, 6:15.
Everyone check to make sure you can get that. You know what to do.
Yep, that's right. 0.75.
We're early.
Well, you guys will have to take your quiz.
We usually only have like 5 minutes.
So what did we get for this? 615?
615.75.
And this be units squared.
I think it's 75.
Yeah.
Close enough.
You will want us to put units squared or units cubed, right, on that.
Probably, just to be thorough. You find that as the higher you get in math, the more finicky people are about stuff like that.
What does finicky mean?
Wanting very specific requirements. They are overly sensitive, I guess you could say. And like, I've seen teachers mark things wrong if like the number's correct, but you didn't have the units.
My teacher used to do that to us.
Why they do that?
Are you like that?
Have I ever been like that?
No.
No, you haven't.
Well, are they gonna do that in high school?
They might. That's why I always tell you guys. I always tell you like get in the habit of this. Like some high school teachers are definitely like that.
My teachers always did that to me.